Hello, yes, it's Salah Nasri here, and yes, I have a special announcement. The Game of Chips has just hit 5,000 orders on Amazon. Thank you to everyone who placed the order. The book was just released in December, so I'm very, very grateful and surprised to date. If you are someone who is intrigued, curious about how the semiconductor ecosystem works from beginning to where we are right now, this book was written with you in mind. So order it, read it, and it is pretty much a handbook of the whole ecosystem. In the meantime, enjoy the next episode and don't forget to hit that subscribe button. Why is it that they're not capable of doing it in-house?
Our customer adoption has proven that what we've built and the time to value that they can achieve really doesn't make sense for them to build. At the end of the day, there's only so many rows and columns of data that you can plug into Excel before it tips over. And it's also offline, it's not secure, it doesn't scale. What our software enables our users to do, there's all these wins that are possible just with scalable math.
Our guest today is Kenneth Smith, Vice President of Growth Markets at SEEQ Corporation.
He has moved from deep technical leadership at IBM to shaping long-term materials strategy in advanced packaging. In an industry that operates under constant time pressure, his philosophy is simple to find the real problem.
How does SEEQ address integrity, data integrity?
Engineers know their data. Like, they can look at a squiggly line and know that if it is at a certain reading like that is completely out of whack, they know, they have the context on it because they know, it's like, I know that where that sensor is, I know what it's coming off of, I know it's wrong. So essentially, an engineer that knows that data can apply a calculation. So as the data is coming through our system from the system of record, it automatically adjusts. What we can do is provide an environment for an engineer to collaborate with the data scientists where they can then publish their models through SEEQ. When you reduce the cost of curiosity, there's no cost, right? There's no pain. Like, if you go down a rabbit hole, we solve problems that we didn't really know existed because we're not penalized if we're wrong.
Which skills, be it process engineering or data engineering or data science, are most critical on modern industrial analytics teams?
We wanted to enable this kind of data-driven ecosystem, right, across from OEMs, facilities, within the fab, assembly and test, right, to where ultimately we can be a broker of not just data.
The more data you collect, the more you're going to be able to identify things. How do you manage model sprawl?
Is we're starting to see it like play out.
Hello and welcome back to the Semiconductor Leadership Podcast. I'm your host, Salah Nasri. And yes, whether you are a industry veteran or someone who's just curious about semiconductor manufacturing or the ecosystem, this is your podcast. Look, in a very short term, we've gained more than 200,000 views. Thank you to all the subscribers on Spotify, on YouTube, and Apple Podcasts. But as the saying goes, it takes a village to raise a chip, and also takes subscribers to raise a podcast. So do me that favor, because in the back end, only 3% are subscribed to the platform. So click that subscribe button, because my promise to you is that I will ensure that I will bring very, very unique individuals in the semiconductor industry who are shaping the ecosystem, that are there to share their thought leadership on what is happening now, what happened before, and most importantly, what's happening next. So today, we have Kenneth Smith from SEEQ. Kenneth, welcome.
Good to meet you.
Pleasure to have you here. So first time in Singapore.
Yeah. Incredible city. Just pretty mind-blowing, really. Yeah. Spent a lot of time here on Monday, just walking around, getting to know the city, going to the local markets, just visiting different places, and it's been a lot of fun.
Awesome. So of course, you're here for the semiconductor community and industry, participating in the Fab Leaders Summit here in Singapore, hosted by us, the International Semiconductor Industry Group. What do you do at SEEQ?
Man, it's a kind of a multifaceted question. We're a scale-up software company, so I wear a number of different hats. But my primary goal is leading growth markets for us. So, as a startup, evolves from early stage to growth stage, you tend to, your focus can get from really, really narrow to a little bit wider, right? And you're constantly looking for those new growth levers. And for us, those are new, could be a new global market, but in my case, it's more focused around a new vertical market. Right. So my primary role is really helping us, grow our footprint in the semiconductor high-tech industry. Yep.
Yeah. So, just sorry to jump in. Why did you, when you look at the growth markets, bravo for choosing for the semiconductor industry. Yep. It's an industry that the world uses in every way and form today. Yep. Why semiconductors, or what made you guys ponder going, let's target this industry, which is a very saturated market to say the least?
Sure. Yeah. Well, your customers tend to tell you when you're onto something, right? Based on the value that they see using your software and product market fit, quite frankly, right? And so we were fortunate here a couple of years ago. We started engaging with Intel, and ultimately we established a partnership where they're using our software across their all their fabs, and we're starting on the facility side. And honestly, it's just an extension. A lot of the things that they're doing with our software is an extension of things we've done in other industries, right? Yeah. So helping them with, optimizing equipment, shifting from time-based to predictive maintenance, saving energy, things like that around all the facilities, mission-critical facilities, equipment, and systems, right?
I see.
And so, we're I like to say kind of a horizontal software play. Yeah. And so helping customers with optimizing pumps or compressors or chillers, things like that. We've been doing it for years and years in oil and gas and pharmaceuticals and chemicals, mining and metals, et cetera. Okay. And so it was just, hey, we've got product market fit here. And then obviously with the emphasis, particularly, where I live in the U.S., the CHIPS Act and all the dollars that are being invested into kind of re-onshore manufacturing. I went to my boss and I was like, hey, we've got product market fit. Intel has confirmed that, and it's a really great opportunity for us to focus on a different market and invest in a different market. And I would just say where our company is in growth stage, as we have revenue targets that continue to, continue to grow, business development, particularly in finding new opportunities to drive incremental revenue year over year, was a focus for our CEO, was a focus for our board. So the timing was just really good. So essentially, I pitched the idea to really start investing time, energy into the industry. And, here we are.
Interesting.
Yeah.
So, this is quite interesting. So elaborate, because this is new to me. I've been in the game for quite a while now. Not that old, but I've seen it all. So what does SEEQ do? You mentioned that it optimizes the facilities, departments of the fabs, because you were talking about pumps and chillers and things. Is that correct? What is it that you guys do? So give me an example of what you guys do when you go into a fab. You go to the facilities team, EHS. I presume it's the EHS folks.
Yeah. Oh, yeah. Yeah, absolutely. EHS, and obviously the reliability team. And so I guess maybe taking a step back on like what our core mission is and why we exist, right? And so we were started by folks that really came from the industrial data ecosystem, if you will. Okay. So a couple of our co-founders came from the industrial data space, right? So most people are familiar with OSIsoft, which is now part of Aviva. Our founding CTO spent many, many years at Honeywell and owning companies in the energy and the industrial manufacturing space. And so, just like a lot of problem statements in the software industry, all this industrial data, timestamp data, time series data was being collected, right, and historized. But for the most part, engineers and operations folks were using tools like Excel, right, for self-service analytics and, kind of square peg round hole or BI software, obviously the big platform approach, right? Okay. And so that's why we were started. And so we were very focused on solving industrial problems, or helping our customers solve industrial problems from the beginning. Okay. So the way that we engage our customers, it's not a kind of top down, we build it for you, or, bring in, kind of these more kind of longer time to value, heavily services driven projects, right? Our primary end users are the industrial engineers, right? The process engineers, the reliability engineers, the environmental engineers. And we provide an application suite that's purpose-built for industrial process data, right? To enable domain experts, getting them out of Excel, right? Getting them out of, not necessarily getting them out of other statistical tools, but complementing those with, scalable, low-code analytics, AI, and industrial monitoring for equipment, processes, et cetera. So typically when we're engaging, any of our customers across industries, it's just sitting down and having an understanding of ultimately what are their pain points? What are the things that map to their, net zero targets, map to their digital transformation efforts related to improving quality, improving yield, reducing downtime, reducing emissions, energy use, all that good stuff, right? And we can help them tackle that with a single SaaS software product.
Okay. Why is it that they're not capable of doing it in-house?
Oh, well, they do it in-house. That's a great.
Well, they use Excel. I mean, do they not consider making their own software internally?
No, I mean, historically, I would guess it's kind of a blend, right? There's always the build versus buy, analysis.
Yeah.
And I would say that our customer adoption has proven that what we've built is, and the time to value that they can achieve and the ROI they can achieve really doesn't make sense for them to build it on their own. Now, what I will say though is we're bringing an off-the-shelf application suite to our customers. We're not bringing a black box algorithm approach with a whole bunch of models that have been developed specific to pumps or compressors or heat exchangers or ultra pure water systems or chill water systems, things like that. We just bring an environment which they can operationalize those things. So that's really when you say what we've seen a lot of companies successful is we're giving them the platform that they can operationalize their domain expertise around, what they do as a company, their domain knowledge relative to equipment optimization or, improving production, things like that, right? We're giving them a framework that scales where they can operationalize that themselves and really empower their domain expertise, right? So it's really just enabling them to kind of accelerate time to value around their goals related to analytics, machine learning, AI.
Okay. Tell me more about these application suite. How is it? Is it like an Adobe Creative type of application suite? Is it on the cloud? Is it?
So we're a SaaS-based, pure SaaS-based company.
Okay.
And as a product company, you tend to kind of evolve over time, right? So initially, we have an application called Workbench, and that was initially built for really low-code analytics, like a lot of the things that engineers were doing in Excel for cleansing data and calculating, applying derivatives or, various forms of linear regression, things like that, right? That at the end of the day, there's only so many rows, right? Rows and columns of data that you can plug into Excel before it tips over. And it's also offline. It's not secure in the sense of, it's just on a laptop, and so it doesn't scale. You can't really collaborate, right? Like you just get all these single versions of the truth all over the place. I mean, when you think about, like a company the size of Intel that's got tens of thousands of people and, thousands of engineers. Yeah. When you've got a reliability engineer at, one fab that's trying to do the same thing as another one of their peers responsible for a different, part of the fab or another side or whatever, you just tend to, recreate the wheel over and over and over again in an offline format, right? And so foundationally, that's where we started was, hey, let's get them into scalable, modern browser-based software with, a lot of the things they've been doing in Excel now available and, with even more capabilities in browser-based software. And so that foundationally, that's where it started. But then our customers were like, okay, great. We can do root cause investigation a lot easier on an equipment failure or a bad batch or, emissions or whatever that might be. Well, now we want to monitor it. Right now we want to, we found out what happened. Now we want to forecast and we want to start proactively monitoring. Nice. So that's where the product's evolved now, which is wide scale monitoring on, hundreds, thousands of pieces of equipment or anomalies, whatever it might be. All particularly, the buzzword of the day is AI, right? So incorporating AI into our product foundationally. And a lot of it's really meant for accelerating adoption, making it easier to use, kind of like, your Apple phone, right? But also more, I'd say, prescriptive AI, essentially being able to tell or an operator, an engineer, being able to go into our software and say, hey, tell me where I might have like a production bottleneck today and why, right? And that's built out over time as you start monitoring things in the software, as you start capturing context. AI feeds off a context, right? Where it can actually, a user can go in and start interrogating the events that we've already detected, the context around those events, to ultimately report back and say, hey, go check this out, and this is why.
Okay. Is this connected to a sensor? Do you have like a sensor that's stuck in the chiller?
No, we don't do any. Yeah, from a hardware perspective, we're going to sit on top of a customer's existing data infrastructure and just make it, help them get additional value out of that. So obviously on a fab, whether it's in facilities or, the tooling, within the fab itself, yes, you have tons of sensors all over the place that are collecting data. Those are then, being brought, written to a PLC, right? Or some sort of industrial computer. And then that's all being aggregated into what's commonly referred to as like a time series database, industrial historian, again, from Aviva or Honeywell or GE, Aspen, right? Or just a SQL, like what we see quite a bit in the semiconductor space is a lot of kind of homegrown kind of SQL data stores where that history data is being recorded, right, and stored. And so SEEQ ultimately connects to those data sources in most cases natively. So our software runs in the cloud. We have kind of what we call a remote agent, but it's kind of a little gateway, right, that allows us to connect to that data. Very similar to like a BI software, but purpose built for making data available from industrial data systems, process data systems, as well as cloud data stores. So whether it's Azure Databricks or Snowflake or a service from Azure, AWS, we can connect to those as well. Because at the end of the day, we live in a hybrid world, right? There's a bunch of data in the cloud that is relevant, but there's a ton of data that still resides on premise.
Yep.
That we can make available for analytics and AI and monitoring for our end users.
So I'd be intrigued to know, I mean, on your personal perspective, what experiences actually led you to SEEQ and pretty much shaped your perspective on time series analytics for industrial operations?
Yeah, it's been, you kind of go where you go, right? Yeah. Like,
was it by accident?
Yeah, it's probably by accident a little bit.
So it's usually by accident.
Yeah, for sure. I mean, if you're someone that at the end of the day, I've my career's been in sales, and you tend to have more success when you're partnering with companies that really like your software and you've got really great software, right? And I've worked for some that it's been, really great, worked for some not so much, or it's good software, just not great product market fit, I would say. So I started off in industrial SCADA, and from a software perspective, started off in industrial SCADA systems, selling into oil and gas. And so I started off in like industrial real-time data, before Internet of Things or industrial Internet of Things was like even a thing. That's what SCADA was called, has been called for years, right? And so you've got, bringing data in off of wells or facilities or equipment or whatever, right? And then you've got a system that's providing supervisory control and data acquisition. And that's how, oil and gas companies obviously monitor their fields, right? Monitor their equipment production, et cetera. So I started there. Went to an industrial IoT startup. So, SCADA is great, but SCADA wasn't built for analytics. SCADA was built to just basically report the news. Like, I want to monitor all my tags that I've gotten out in my field on all my wells or, my facilities or my pipelines or whatever. I want to know, obviously, from an EHS perspective, and most importantly, tell me when a threshold, right? We're below or above a threshold, an alarm off of that, but they weren't built for analytics. This is, before those were really even a thing. Right. So I went to an industrial IoT startup, which was really their value proposition. Hey, we're going to aggregate data from industrial systems, right? As well as that was kind of the beginning of the IoT days and industrial sensing or additional industrial sensing. So we can merge your SCADA data with your IoT data, bring it into a single environment, and then you can build applications on top of it. Product market fit wasn't great there. Companies found it really difficult, I would say, from a time to value to ROI. The software just, it was probably just not ready for scale. So I left there and went off into the open source world. I went to Hortonworks, which was a publicly traded Hadoop company. And that was really big data, right? The word of the day was big data, Hadoop, born out of Yahoo, born out of Google, indexing the internet. Well, if you can index the internet, you can index any kind of data, which you kind of can. But I would say that what I've found with industrial companies is the technology evolves much more quickly than they're able to upskill, particularly from, scalable compute, Hadoop, and all the different ML capabilities, I would say, that have come out, say, in the last, 10 years, right? And I learned a ton at Hortonworks around kind of strategies relative to enterprise data management. But again, a data lake is just a data lake. You have to have some sort of application on top to ultimately deliver said data to the consumer, or to to do something with the data to actually drive business transformation and impact. And so I was pretty fortunate that ExxonMobil was one of our largest customers at the time, and when I was at Hortonworks, and they plugged SEEQ. SEEQ was one of the applications they were plugging into what they called their manufacturing data lake. And the first time I saw it, I was like, oh my God. It was the first software I'd ever seen that resonated with my background, right? Because at the end of the day, like a big part of a SCADA system are kind of squiggly lines, right? It's the time-stamped data of, get a temperature measurement or a pressure measurement or whatever. You got your squiggly lines. Well, that's how engineers and operations folks more times than not want to see their data. When I saw SEEQ, that's the Workbench application I mentioned to you. That is the visual interface, are squiggly lines, right? And I'm like, okay, this is interesting. And then I just started hearing more about it, and actually reached out to the company. At the time, I essentially managed our oil and gas kind of energy practice, and I was like, and we needed application partners, right? Because again, you're going in and talking about a data lake. Well, you say, hey, this company's doing all this great stuff with a data lake. Well, how are they doing it? Well, they've got a bespoke application they built, or they're doing it in a BI software, or, well, it's like, oh, they're doing some cool stuff in SEEQ, right? And the more I got to know the company, the more I was intrigued. I actually referred a friend of mine over there. He was in a position where he was looking for a new gig. He went over there first. I'm like, hey, man, how is it? And he's like, it's awesome. It's everything that, we can sell this everywhere. All of our former customers in oil and gas absolutely need this, would use it. It's great. So that's kind of how it started. And here I am. And I've been here it'll be 7 years this February.
Remarkable. So out of the blue, how did Intel come into the game? Did they reach out to you?
They found us.
They found you guys.
They found us, yeah. It's
is it customizable, the work that you guys do? So let's say, for example, like an Intel, it's a huge, one of the biggest IDMs in the world.
Yeah, sure.
They're with fabs all over the world.
Yeah.
Is it customizable? Is it pretty much the standard software just goes in and does the work?
It's really one of the great things about what we do is, at the end of the day, industrial timestamp data, right? Industrial time series data, process data is the same across every industry, right? Like it's measuring something, and there's nuances to what the process is, right? Like. Manufacturing wafers is completely different than making pharmaceutical drugs or specialty chemicals or something like that. But at the end of the day, it's either like our focus is on process manufacturing, whether continuous or batch. So you either fall kind of into a continuous type process or a batch type process. And so like facilities is continuous, right? And in the clean room itself, it's going to be more kind of batch. No different than like in the pharmaceutical space. When we're helping them on the facility side, continuous. If it's drug production, right, it's going to be more batch manufacturing. So, but yeah, they found us actually. They had a project that that they called their discovery program that ultimately was, hey, we want to really double down and invest in robotics and AI and analytics and that kind of thing. And so they were actively looking for products that fit their needs relative to the types of use cases that they were looking to achieve, and their reference architecture that they had already put together.
Interesting. So basically, the soft spot for SEEQ is basically the subfab.
Subfab facility, subfab right now. Right. Yeah. So I'd say that again, they're the types of use cases relative to pivot from, say, time-based to predictive maintenance, reducing energy costs. Looking at, building, kind of automated strategies relative to triggering work orders, whether it's, predictive maintenance on filters and HVAC, or, obviously, within facilities, you have tons and tons of redundant equipment, but, ultimately what's your strategy for managing all that, from an energy perspective, as well as a maintenance perspective. And then, so we're hoping to grow into the fab, there, but, I'd say that, we've really invested this space now for over a year. We're members of Semi, we're
Members of us as well.
yeah, members of you guys, we're members of, obviously, the, Fab Owners Alliance and other industry associations. And I see this kind of similar to oil and gas was about 10 years ago. There was apprehension around, cloud, right? And, leveraging cloud and SaaS technologies. But, everybody wants to talk about AI, and, those two things are kind of difficult to mix together. If from a data access perspective, if, SaaS software is not going to be entertained, right? And so there's lots of conversations about it. It's like data availability, making data available to SaaS software, whether in facilities or within the clean room itself, within the fab. And, I think it's going to kind of boil down to the, balancing the risk with the risk appetite, right? With the potential rewards that can be achieved by leveraging more modern SaaS-based technology.
So for listeners new to SEEQ, what are the core pain points that you address in working with high volume, high velocity industrial process data?
Yep.
And I want to pick on 3 key areas: time series, events, and contextual data.
Yeah, that's great. Yeah, so I would try to break it down, I guess, into kind of 3 buckets. So first of all, data availability, and time to value associated with that, right? So historically, there's a philosophy that you have to kind of get your data out of your on-premise source systems, like into a centralized environment before you can, start doing anything with it. And we flip that paradigm, the other direction. And so we're like a BI software purpose built for industrial time series, and the way that we integrate is ultimately to establish a connection with those source systems. In most cases natively, right? We have native connectors built for most of those systems that I kind of referenced earlier, right? The Pi system, GE, PhD, Honeywell PhD, IP21, et cetera. And so our deployment is very quick, very rapid. And, days, weeks versus, getting all of your data into a centralized environment, building a model, all that stuff. Like, what the pain points that companies have felt trying to do that with their industrial data is, very, very long from a time to value perspective, and typically heavily professional services driven, with just a lot of sunken cost before you're even starting to look at, building applications and delivering outcomes to the customers. And so that's number one. That's one of our primary value propositions, is very, very quick systems integration and deployment. In fact, we support our customers through success plans, right? But unless it's a really, really complex data integration project for whatever reason, or we got to build a new connector, things like that,
right?
There's typically not a lot of money that's invested in actual system integration, right? Making that data available. So that's number one. And then we are purpose built for time series data. So our software knows how to, from a data security perspective, from managing latency. Like, a lot of these old systems don't like to be poked, right? And so you've got to be, there are nuances to making that data available quickly, right? To where you're mitigating latency, but also from a security perspective, right? We are moving or connecting to plant floor data. And keep in mind, we have close to 300 customers. 95% of our customers leverage our SaaS software all across the board, right? From large oil and gas multinational companies to multinational pharmaceutical companies, right? So from a data security perspective, our approach has proven to be allowed by the information security teams, right? For the companies we work with. So we've put a lot of money into encrypting data, right? And again, just how we deploy. And then from an I would say, an event data perspective, SEEQ's very visual in nature. And so we make it really easy for an engineer to see their time series data, their sensor data. So temperature sensors, vibration data, or flow data, flow rates, or whatever that might be, and overlay context, right? So event data. So like downtime events, like historical downtime events, or periods of operation where a piece of equipment was in kind of an anomaly state, or batches that were not up to spec, right? So we make it really easy visually, not just being able to connect to those sources like a Maximo or, another asset management system, or, a LIM system, things like that. But we can very simply help them visually overlay those things. And then from a context perspective, there's a number of different ways that you can actually input, or an engineer, a user. Like, we have about 70,000 users of our software globally now. And again, they're all engineering operations personas. And so, they want to share information, right? And they, like, if I'm a reliability engineer at one site and you're a reliability engineer at another site, and we ultimately are responsible for the same type of equipment, that's the beauty of SEEQ. Once you get people out of the spreadsheet world, and you can kind of start establishing standards for how we're going to monitor this, how we're going to monitor that, then it really makes it a lot easier when everyone is speaking the same language to collaborate. And so we have a number of different ways that you can capture context. But in our monitoring product, as you detect, or as the software detects anomalies, you can actually categorize those anomalies. Someone can go and investigate, right? So a technician goes out in the field and, okay, we had a bearing failure, or we had a squirrel that chewed through, an electric line, or whatever it might be. This is what happened. Well, all that context can then be associated with the events. And that's all fuel for AI, which is what's becoming more and more powerful. And I've honestly haven't seen, I'm not going to say I'm an old head and been doing this for like 40 years, but I've been doing this for 15 plus. I've never seen something, a technology that has accelerated, the insights, or just the ability for our customers to not just get, I would say descriptive analyses, but more prescriptive like this. It's just incredible. But it's all fueled by context, right? If you have the event associated with the process data, associated with other potential, like weather as an example, or feedstock information, or when a piece of equipment was deployed, how many times it's been maintained, and then really, again, our core value prop is the SME. The domain expert is in the middle of all of this. They know their data, they know their processes, they know their equipment better than anybody, and we provide an environment in which they can perform their own analytics, monitor, and then start applying AI once you start capturing all that context within the software. And that's what we feel like is our key differentiator, is really amplifying domain knowledge, right?
I mean, my team, when they were doing the research and they passed me on the information, I think it was referred to SEEQ's analysis tools, sophisticated yet easy to use.
Yeah.
And I presume that kind of supports the traditional tooling process that they're normally used to.
Yep.
But it's interesting to, of course, identify how it actually generally accelerates, from what you said, the troubleshooting and optimization. But what would be interesting to understand is like, what does a typical first 30 to 90 days look like for a customer? Let's say, for example, Intel, when you started working with them, from connecting data to delivering a measurable win, because I'm sure there's some KPIs attached to that.
Yeah, 100%. So, I mean, first and foremost, one of the really great things about SEEQ, but also can be a little bit overwhelming, because it's just, we can enable a customer to achieve all kinds of results relative to just timestamp data, right? Like, as I mentioned before, equipment reliability, energy optimization, improving yield, quality, things like that. It's like, where do you start? So, you don't want to boil the ocean. I mean, that's still truth. Going back to, it's like fail fast, all the things that people have said for forever, right? Find those wins at the, the ROI justifies kind of the time investment, things like that. But, again, I think one of our key propositions, value props, is that time to value, because we're not a big IT project to ultimately, perform the data or help our customers integrate with their source data systems. And it's not like bringing people to build something for them. At the end of the day, we're just activating that, we bring the activation energy of how to now, like, it's so true. No one wakes up, we've heard this from multiple customers, like, I don't wake up every day to learn a new piece of software, because there's been so many things that have been rolled out that haven't worked. And so there's fatigue, right? There's technology fatigue. And so at the end of the day, you need to have, product that's very compelling. You need to have an enablement plan that's compelling, and an adoption plan. But, I'd say specifically from an end user enablement, we've done a really great job of building out our enablement content that engineers really like to get on board with and learn how to use our software. So I would say that all the aside, let's just say pre-sales process is already done, and we've got, we're working with a customer, we've got a contract, right? Typically, from a security perspective, all that's been done. And so it obviously starts from a data integration perspective. If it's one of the things that we just connect to out of the box, that's typically something that happens in a matter of about a week. So, let's say a company has 4 of those standard, like, process historians, right? So a customer is going to provision one of these little remote gateways that we connect to alongside, on their network, alongside their data sources. So again, that could be, obviously our, reason for existing in this world is their time series data stores. And then ultimately we'll stand up a SaaS tenant, and those two things will start talking, and we essentially bring in all the metadata from that source system. So the metadata being all the hierarchy, right? So all the different tag names associated with the equipment. If they have an asset hierarchy where they already have things grouped together, it's like in the Pi world, it's commonly referred to as like Pi Asset Framework, Pi AF. That's essentially taking those underlying tags with all those weird names and grouping them into pump 1 through N, compressor 1 through N, right? Like names with all the tags in the background. So we inherit all that into our software. And so what's cool about that is that as an end user, your names of your data in SEEQ look exactly the same as they did in your historian, where, that's typically, you're going to have an HMI, right? Where you're operating, right? That's what you're used to seeing. Yeah. And so once that's done, we have some sort of enablement plan. So we have on-demand learning that we provide. We have remote instructor-led, for really large customers. We still do quite a bit of on-site. So we're typically working, like in the Intel case, or just any large company, particularly I would say where we are aligned with a strategic adoption plan, right? This isn't we're going to start working with a few people. This is, we want to take this and roll it out everywhere. And we've done this 100 times over, right? Across our customer base. And so we're typically working with a project manager, ultimately to identify, like, we're not just saying, hey, let's shotgun and just make it available to everyone. Typically, we're kind of working with, say, like a reduced set of folks that are going to be key, like the ones that have been identified that have an appetite for learning new technology, that have proven to have an appetite for data, right? Like taking data-driven approaches to solving problems. And then we're gonna go enable, right? So we're gonna go from site 1 to site 2 to site 3 to site N, whatever it might be. And also while also providing that on-demand learning experience. So there's the enablement part, but then it's also focused use cases. So, okay, cool. While we're enabling these people, what are the primary things? And at this point, we've already identified those. It's like, we're having reliability issues here, or we're having production issues here, or we really need to reduce our energy costs, or we need to, look at more predictive maintenance strategy relative to equipment XYZ, or whatever it might be. And so, one of the key parts of SEEQ that's a little bit different, all of our folks that our technical team that's working with our customers, our end users, engineering operations folks, they all come from the field. So I can't even tell you how many of our former engineering customers are now in solution consultant capacities for SEEQ, or what we call analytics engineers. So these are degreed chemical engineers, petroleum engineers, folks that come from the semiconductor world, the pharmaceutical world, oil and gas, chemicals, et cetera. Like, they've been doing this as their job, that now come work for us, and in many cases have used SEEQ and their previous employer, and they are now the ones working with our customers on helping them apply the software to their problems. And the really great thing is like they've lived that day in the life.
Right.
So they bring credibility, they bring context. All they're really bringing is, hey, I'm your accelerator. Like, I was in unit operations just like you, or I was a process engineer in the fab just like you. I know your job. I know your day to day. I did it for one of your competitors, right? I know how to use SEEQ. I'm just going to help you very quickly adopt SEEQ and apply it to the problems that you're trying to apply.
Fair play.
And so, just to give like a customer example, Chevron Phillips was one of my customer early days. They turned a 5-figure investment into a 7-figure win in less than 90 days. And that's common. Like, it's not uncommon at all for a company that we engage to find, just round number, $1 million payback within, 30, 60, 90 days of using SEEQ.
Wow.
Because you don't have the sunken cost of a big IT project where, you're spending whatever that costs. It's a lot out of the gate just to aggregate your data, get it in one spot. And then it's like, okay, now we can start actually working on, a use case. Like, and the other great thing is because we are distributing, it's really a cultural thing, right? Like, industrial companies tend to be extremely risk adverse. And so like we allow them to take risk as it pertains to their data because we're not messing with the system of record. We're just making the data from that system of record available for them to start exploring. And as engineers have hypotheses, they can just start digging in and testing out those hypotheses on their data, but we're not touching anything that's in the system of record, like in the historian, right? We're just making it available for them to leverage and SEEQ. And so what a lot of our customers have said is like, you completely reduce the cost of curiosity. Like, we don't have to go and ask the system admin for, hey, we need 5 years worth of history for these 20 signals for this piece of equipment. Send it over here so I can start messing with it. Oh, actually, I need these other 5 signals, and it's just there. It's available. And so like when you reduce the cost of curiosity, there's no cost, right? There's no pain. Like if you go down a rabbit hole on a particular use case, you're trying to like, I think it might be this, and it doesn't work out, there's no cost to that per se, right? And so we've had so many of our customers that are like, we solve problems that we didn't really know existed because we're not penalized if we're wrong. You know what I'm saying? Like that cost of curiosity is gone because the data is just available. We can just start figuring out what might be going on with a bad batch or equipment failure or whatever it might be.
So it seems to be, one of the frustrations that kind of you faced previously in the other companies, which weren't a great market fit, would have been connected to the scalability and maintainability of things. What would be interesting to understand is currently with SEEQ, what patterns help customers avoid, and there's that terminology, model sprawl, and keep analysis versioned or governed and reusable across sites.
Yeah.
And also, I'd be also intrigued to understand is that, one of the most sensitive topics is the data sharing in our industry.
Yeah,
of course.
Yeah.
So, but the thing is the more data you collect, the more you're going to be able to identify things. So that, something might happen at an Intel fab, then something might happen at a Micron fab, which will be different.
Yeah.
Something might happen at a GF fab. Something might happen at an Infineon fab. And they've got all different climates, all different situations. So I'm really intrigued to understand is how do you manage model sprawl?
Yeah. So, most of what we're doing, or I shouldn't say what our software enables our users to do is a lot of, it's not even really, it's more calculations. It's not even models necessarily. Like Intel just did a webinar with us last week or week before, I guess.
Okay.
And Manoj, who presented, was talking about there's all these wins that are possible just with scalable math, basically, like common methods related to data analytics. All right. Like, yeah, in other words, don't boil the ocean until you think you have to. Right. And so a lot of what our users are achieving in SEEQ is just done with scalable math, low code regression models, things like that really don't require, I would say, data science, someone from a data scientist getting involved in like deploying a model. All right. But what we've learned over the years in working with really large customers is, to your point, we have to provide a way for them to start capturing best practices related to calculations models for certain pieces of like common equipment types and things like that. So our customers can do that. We essentially have like a corporate drive where they can start organizing, hey, this is our rotating equipment kind of library, or this is our, whatever it might be, right? But a lot of that, I would say, more complex model management, version management, things like that. I wouldn't call ourselves a data science platform. Like we can enable, like we do have a coding environment, a Jupyter environment where, process engineers or data scientists that, have those skill sets can go in and do a lot of prototyping and things like that. But more times than not, if it's going to be a model that's going to be shared or distributed across, a wide variety of people, they're going to be doing that in probably Databricks or, Azure ML or AWS SageMaker or something, like whatever their corporate data science platform is. But the great thing about SEEQ is that model that data scientist develops can be deployed in SEEQ and operationalized. So like one of the common challenges that data scientists have is it's like, okay, I've got this really great model. How do I get access to the appropriate data that's contextualized, like cleansed, contextualized? Because I don't know compressors. I don't know a clean room. I don't know anything about a tool, right, in the clean room. But the engineers do. Right. So what we can do is provide an environment for an engineer to collaborate with the data scientists where they can then publish their models through SEEQ, right? And using data that's contextualized from an engineer. So an engineer can basically say, hey, Mr. and Miss Data Scientist, here's what I'm trying to accomplish. Here's my cleansed, my feature-enriched data set. So I've already done that heavy lift for you. This is good to go. Please start working on a model, and then let's, test it out. And then when it's ready to deploy, they can deploy it in SEEQ where it's then consumed by all these engineering operations folks, right? Or they can just, deploy a little applet or something in SEEQ. And so, one of the biggest challenges is the cultural thing, right? It's not yes, the data challenge is real. I like to say that, we help our customers knock down not just data silos, but people silos, and enabling personas to start collaborating in a common environment to accelerate, right, the types of outcomes they're looking to achieve.
So if when you're looking at calculations to ML, where do classical processes, or where does classical process analytics end? Yeah, and ML begin? Yep. In SEEQ workflows. For example, where ML forecasting provided step change value, for example.
Yeah. So I think it really depends on the use case. And I'm not going to pretend to be a data scientist, nor am I a process engineer, right? I'm not an engineer. So, if Sean were here, my colleague, he could tell you. I think it comes down to the SLA around like what's the problem you're trying to solve, and if you have a early enough warning using more traditional methods that you can do natively in SEEQ, great. If the problem that you're trying to solve requires, or let's say it's multivariate problem versus like a univariate problem, right? Like it's not here are 6 signals and give me one answer, one prediction for these 6 signals. It could be, again, multivariate in, multivariate out, which is going to be a more complex problem that needs to be solved with like a random forest algorithm or, whatever the data scientist might use. So I think it really depends on the problem. But I think, again, one of the great things is like engineers have their viewpoint of the world, data scientists have their viewpoint of the world, but more times than not, there's a wall between them, right? Yeah. And so I think, and you could probably bring in, 20 people and they would give you 20 different answers of what you just answered, and they're going to be way smarter than me about it. So I would just say what I've seen in my experience is that we break down that wall. And so whatever the right approach is, our customers are able to figure it out much more quickly because we are enabling them to combine the process engineer's domain knowledge with the data scientist domain knowledge and actually see tangible results in the form of data where they can validate, is this just a math kind of approach, right? Is it just a linear regression, or is it more complex neural net or something like that a problem that needs to be tackled by a data scientist?
So from that perspective, then how does SEEQ address data integrity?
Yeah. So, well, I mean, at the end of the day, we aren't, again, we're just sitting on top of what you mean from a security perspective, the actual quality.
Quality.
Yeah. Data quality. Yeah.
Data quality.
Yeah. Good point. So like, again, engineers know they know their data, right? Like they can look at a squiggly line and say, okay, that's a really good question. They can look at a squiggly line and know that if it is, at a certain reading, let's say it's a temperature pressure or something like that, that is completely out of whack.
Yeah.
They know, they have the context on it because they know, it's like, I know that where that sensor is, I know what it's coming off of, I know it's wrong, right? Or let's say that, then a data scientist doesn't have any context, right, at all. So an engineer, if they need to, let's say that there's a bad sensor or, at the end of the day, we just inherit what's coming from the historian. So they can ultimately apply calculations to that data to normalize it, or to change the unit of measure. It's pretty common, like we have data that's being collected off of, from one side, data that's being collected from another side in another country, and you need to normalize that unit of measure. They can ultimately apply calculations in SEEQ. So as that data, raw data feed that's coming through SEEQ, the calculation is automatically applied and adjusted to, again, from a data quality perspective, whatever it is and what it should be, it can be adjusted in SEEQ. So essentially, an engineer that knows that data can apply a calculation. So as the data is coming through our system from the system of record, it automatically adjusts, right? Whereas a data scientist without context is going to take the data for what it's worth.
Right. Out of interest, I mean, this might sound like a blasé type of question. How are you perceived by, when you look at a normal fab, all the pumps that are there, it's either Edwards, Bush, Pfeiffer, Ibarra, these guys. How do they perceive your work? Have they reached out? Do they look at partnerships with you guys to enhance it? Or, I mean, even the chillers, MKS, these type of folks.
So we are actually having conversations with a, OEM service provider.
Okay.
Now, I can't name their name.
That's all right.
But they are not just a semiconductor, but they're very prevalent across really all industrial verticals that we support jointly. They have kind of their own technology for kind of an IoT platform. Let's just call it that. But one of their biggest challenges is data access. So they can get access to data coming off controllers that they deploy in the field, but their customers don't give them access to all that other process data, right? So you brought up a really good point around, and I meant to address it before, data sharing.
Right.
So what we're seeing emerge more and more, and it speaks to this example that I'm saying, are for our end user customers that are working with the pump providers, the fixed rotating equipment providers,
abatement,
whomever it might be, right? The OEMs, or in the case of like pharmaceuticals, where you have, or in a case of pharmaceuticals, where you have a drug designer and then you get a contract manufacturer, right? Is the ability for those two companies to collaborate on the same data set in a secure manner, right? So we have, within our software, we have a capability we call it third-party data sharing, where like we have a refining company that basically for all of their OEMs, they're starting to say, you need to use SEEQ so that we can share, like let's say it's a pump. We're having some anomalies with a pump. We want you to help us solve the problem. You need to use SEEQ. So OEM using SEEQ, our customer using SEEQ. Our customer can share, let's say it's whatever the number of signals. So let's say over an 18-hour period, they had a downtime event for 20 signals. They can share just those 20 signals over that time with the OEM, where they can collaborate in real time or collaborate on solving the problem, applying calculations, looking at figuring out what's going on. And we're also seeing that with our contract manufacturers as well, where they are being asked to share batch data, right? Coming off of coming out of their plant with the drug designer as an example. But in this case, with in the semiconductor space, very similar thing. The company that we're talking to has their customers won't give them access to the process data aligned to the IoT data that they get in their platform. And we have a common customer that's like, we want to see you guys have SEEQ so that we can share
that data.
Yeah, that data securely, but also with context in the amount, like the time window only, right? It's not, hey, here's a year worth of history. It's, nope, we've had these downtime events that happened. One happened last Tuesday, one happened yesterday, one just happened 5 minutes ago. We want to share the relevant data over the relevant time period with just that. That's all we want to share with you. And the OEM's excited about it because they've got all this domain knowledge relative to the equipment, the systems that they support that they want to protect, right? They want to protect their IP. So what we can enable them to do is essentially deploy, take their model or apply their model to the data coming from, our customer, our joint customer, and then send them a result back, or, deploy an app or something like that. So like my vision when we first looked at the industry was that we wanted to enable this kind of data-driven ecosystem, right? Across from OEMs, facilities, within the fab, assembly and test, right? To where ultimately we can be a broker of not just data, but information across that ecosystem. And what's been really cool is we're starting to see it like play out, right? Like we're starting to see where it's like, hey, this customer, go work with this, and the OEM saying, yeah, we just have a problem with data access, so you would help us solve that really, really well. And your customer uses SEEQ, and
goes hand in hand.
Yeah, 100%. So it's been really cool.
Looking at the talent per se for a company like SEEQ, which skills, be it process engineering or data engineering or data science, are most critical on modern industrial analytics teams? And what would be interesting to know as well is how do you grow them?
Yeah, so that's a good question. I think, what we're starting to see more and more, and actually, I'm been having some conversations with Texas A&M, University I live in College Station, and trying to find ways for SEEQ ultimately to get involved with the petroleum engineering school or the chemical engineering school, where SEEQ could be deployed like as part of a lab environment, to where students can actually have something that's like very real, very tangible, and have a skill set to learn how to leverage or take their modern analytics skill sets, right, and actually apply them right, and that's relevant, or internships, things like that, which we've done with some schools. So we're starting to see, and I would say with a lot of the engineers, whether they've been with the company for a while, they're coming out of school, is they have coding skill sets. Like they want to learn coding skill sets, right? And of course now AI, it's like A&M has this new like dean of AI, right? That's in the Mays Business School. That's going to ultimately also have some, is building out what is the AI curriculum for a business school or an engineering college, like A&M. What does that look like? And so I think that, and we're seeing that within our customer base too, where you have, I can't tell you how many engineers turned data scientists that you're seeing now, right? That are going back to school to learn Python, to learn coding skill sets, and they're kind of a unicorn, man, right? Like if they have that domain knowledge and they're a chemical engineer, petroleum engineer, and then they've got a coding skill set as well, so they bring domain knowledge to solving a problem with whether it's a traditional a traditional method for analytics versus like a data science or an AI driven approach or whatever. So I think that's really important, because you're always going to have people that are going to be, and all this really comes in a kind of a cultural change management thing too, right? I would say that, particularly for a lot of the industrial companies we work with, getting them to change a mindset relative to becoming data driven and becoming more like rewarding risk in the sense of, I'm going to take a risk of having a hypothesis and going and exploring, using something like SEEQ or whatever their data science tools are or platforms are, and really, digging into the data and taking a data-driven approach to solving a problem. That historically necessarily hasn't been like rewarded, right? So I think more and more companies are pivoting to where they reward people that have that appetite for that risk, right? Yeah. And so, but I think that's one of the big skill sets that we're seeing emerge is process engineers that at the end of the day have gone and upskilled and are learning, ultimately coding skill sets, right?
Okay.
Going back to school to do that. That's, and I think, so, I mean, I would say that's my perspective, right? And I think it's SEEQ. We've got a number of them that demonstrate those skills and themselves, right? And that are helping our customers do some really, really cool things. Because, like, at the end of the day, yes, by and large, what we help our customers do is solve those problems on their own. But a lot of times, in the proverbial, you have to teach them how to fish. You have to lead by example. That's one of the things that we're seeing emerge is process engineers with skills, more coding skill sets that are kind of bridging that gap.
So I in a previous podcast, I had the Fab Whisperer, and when I asked him which roles will not be replaced by AI in the future, he said maintenance.
Yeah.
Do you agree with that in terms of the subfab from a maintenance standpoint?
Yeah. I mean, I think like someone still has to go out there and turn a wrench, right?
Yeah.
When something breaks.
Yeah.
And I obviously, lights out manufacturing. That's like the future statement. Everyone's talking about that. I mean, I think we're obviously a little bit of ways from that. But yeah, I mean, I think you can apply that to like, I've got 3 boys that are 10 through 14, and as they're getting, it's like, are they all going to go to college? I don't know, and what but you always have the ones that don't tend to enjoy academia, right? It's like, okay, well, go learn how to, you could be a welder. I mean, you could go be an electrician. You could be an HVAC specialist, whatever. I mean, those skill sets are, I mean, they're already, super high demand, right? Because there's not as many trades people coming out of school as there used to be. But you think about, I mean, all the data centers that are being built and the chip fabs and stuff like that. Like when you tour one of those and you see just that all the stainless steel, tubing and just all the stuff that goes into a fab or a data center. And so yeah, those aren't going to go away.
No. So over the next 3 to 5 years, Kenneth, what shifts in terms of AI co-pilots for engineers, or autonomous optimization loops, or new data sources will most transform plant operations?
Oh man, I think foundationally right now. So,
to the next 3 to 5.
Yeah, next 3 to 5 years. Man, I mean, I know there are companies that are focused on autonomous control and like closed loop. I think that's further out. I mean, that's going to be probably more on the 5-year horizon as companies become, again, it's a risk appetite, right? Like, everything that we do keeps the human in the loop, where even if it's an automated workflow, there's someone that essentially says, yep, this is good, sign off on it, right? Like, yep, that's good. But, we aren't writing back to a PLC or anything like that, or, we're a couple levels above that. So I think initially it is probably, a chatbot or just like, an AI-driven interaction, from a software perspective. That's going to be kind of the first step. And I think, most, like, if you don't have that as kind of core to your product, like, you're already kind of going to get cooked anyway. You're probably behind, but I think there's a step in the middle, which is the pattern that we're seeing emerge, which is like MCP, A to A, where agents can communicate with other agents, and there's still a lot of standards. Like, who's going to emerge is like the most secure protocol that everybody is comfortable with from a security perspective in allowing agent to agent communication from system to system, because that's a step change that we're already starting to see. So I'd put that probably in the middle. So like foundationally, yes, it's going to be just the ability to apply AI to start asking questions of your data in whatever thing that is. I think in the middle is where kind of the example I gave before, like we've got a customer called British Sugar, and they presented about this at one of our user conferences, and they're one of the early adopters of our more advanced AI capabilities, where they've monitored things in SEEQ, so they've detected anomalies, they've got context there, but then our agent is also sourcing information from data that resides on their network, right? So historical production data, feedstock, I can't remember what all it is. And essentially they can go in and go, hey, tell me where I'm going to see a production bottleneck today. And it'll spit out an answer. And that's because it has additional context, right? So I think that is the next step change. But right, like even for, I think the hard part, it's like, you've heard about like OpenAI as a services company now, right? Accenture is pivoting to AI, like AI services, like is foundational to their growth, because companies, what AI is unlocking is you don't have to move your data all onto a centralized location to do something with it.
Yes.
Right? You can have agents that are kind of scattered out all over the place that know their systems really well, that are communicating with each other. So that's the next like big step change, where that becomes more, I would say, productized, where there are standards that emerge around enabling that capability, because that's just going to unlock so much cool stuff, man. I mean, we're already seeing it.
Yeah.
We're at the very beginning of it,
Yeah. It's going to be a crazy few years coming. To wrap up the session, Kenneth, and thank you for this wonderful podcast discussion with you. What's one piece of practical advice for leaders, let's say, fab leaders out there, staring at messy, siloed historian data and wanting results this quarter?
Yeah. So we've talked a lot about this, like in industry forums, right? And AI is a rage as it should be, but there's the risk appetite. So, and I get it. There's obviously data security and IP concerns. Start on the facility side. Like, I guess maybe I'm not looking at it in the light that they do, but is your data relative to your pumps running or your ultra pure water systems, your chill water, your chemical abatement or gas systems, things like that? Like, is that really IP? Right. And so, if you really want to take advantage of AI and how quickly it's evolving, like SaaS software is like table stakes, right? And also just the amount of data that a high volume fab has, or any high volume manufacturer for that matter. Like, you need scalable compute. Like, you can't just keep throwing resources on a physical server or VM or whatever, right? It isn't, and you're also just, again, as rapidly as the LLMs are evolving, by partnering with the SaaS software company, you're going to get the latest and greatest functionality that is, that being included, right? The features that are being included as part of the software. So start there. Like, start on the facility side. There's a ton of opportunity, particularly if you have, whether it's new, but particularly old facilities where you've got aging equipment, and the alternative is like, significant capital costs to, replace all that equipment versus keeping it running longer and leveraging, AI capabilities to, again, lower energy costs and, meet net zero targets and, reduce maintenance costs and things like that, right? All the opportunities that are available there with that, mission critical, because obviously their number one job is ensuring, 100%, right? Like 24/7, 365 supply to the fab. So start there, because you got to kind of take that jump. Again, like 10 years ago in oil and gas, no one wanted their data in the cloud.
Right.
And now all of them do it, right? And so I think that's the place. And also, I guess what we feel like our value proposition is, that doesn't require you to invest a bunch of dollars in services, right? You're activating, not only is there an opportunity to capture business value relative to all the things I said, reducing energy costs, maintenance costs, et cetera, you're activating your domain expertise, right? You're changing your culture. And ultimately, every CEO is thinking, how are we going to leverage AI to impact business across our company? Like, how are we going to do it? Well, that's what we're seeing our customers do, is we can help them do that right now, right? We can help them do that now. We can help them start to change their culture, ingrain a data-driven approach, right? A data-driven culture.
Yep.
And activating, because what I like to say is, like, you're never going to realize the full potential of an analytics program or now AI, right? You're never going to realize that full potential by trying to build out, work products through a centralized kind of data science team and distributing that and publishing that out to your people. You're never going to be able to do it. You've got, if you're a 50,000 employee organization, even if you have 100 data scientists, you've got 10,000 engineers or whatever the number is, right? So you're going to see way more incremental and long-term business value by activating those 10,000 people. Yeah. Also these people too, right? But just knock those silos down, enable them to work together. But I would say that, from an AI perspective, facilities, like starting facilities, low risk. There's not, I think the IP concerns there is in the clean room, and you can see some really quick returns.
For a final message, Kenneth, if listeners remember one thing about SEEQ's approach to industrial process analytics, what should it be?
Yeah, amplify your experts, man. Like amplify your experts, and our approach is, we enable your experts with our capabilities for, what we feel like is the shortest time to value to ROI in the industry, right? Like you've got to see that payback in order to justify more investments. I would say, the days of just moving data around are kind of over. Not to say that there's not a reason to centralize data. Of course there is, but what happened during COVID, there was a bunch of data that got migrated into the cloud, right? So that it was made available to a distributed workforce, and ultimately, at the end of the day, starting to hire headcount to do something with it versus just manage like on-prem infrastructure. But I think there's so much opportunity to go ahead and leverage what you've already done from an infrastructure perspective. Like you don't have to move data around anymore to get value out of it. And that's so kind of our key value proposition is wherever you're at in your journey, whether everything is on premise or you've got everything in the cloud, or most cases it's somewhere in the middle, right? We can help you get value out of that really, really quickly with your people doing it, right? And so what does that mean? It means that it's not just short term, but there's incremental, significant ROI that you can achieve because it's not just someone parachuting in, building some stuff for you, and then they leave, and then they come back, and you spend more money with them, right? Like you're ingraining those capabilities within your company to ultimately improve all the things we've already talked about, but big picture, meet net zero targets, improve shareholder value, right, and grow your company and meet the demands of your customers, right? So that's what we can do.
Awesome, Kenneth. It's been a pleasure having you on this.
Great meeting you, man. Really appreciate the opportunity.
Yeah, definitely. I mean, we definitely need to have another podcast and go a little bit more deeper when you've got the other case studies out there. I mean, you're in Intel now.
Yeah.
So
those resources are available online. The recordings on our website and stuff. So
So I'll be intrigued when it goes to all the different other fabs out there and see what's changed and how it's working. So ladies and gentlemen, thank you for joining us on the Semiconductor Leadership Podcast. Again, if you would like to reach out to Kenneth, his LinkedIn profile is just below here. You can click on here and you can connect with him directly to explore more about SEEQ's opportunities. As mentioned, if you enjoyed the episode, please share, like, and comment. And most importantly, hit that subscribe button. Other than that, I will see you at the next episode. Until then, take care and bye for now.